Good evening, everyone. Welcome to the live chat for Tuesday, April 22nd, 2025. Of course, I'm your meteorologist, Stephen DiMartino. We have a lot to talk about tonight. First of all, we have the book of the week, which I'll share in a moment. We also have a wildfire, and I found some great social media uh, advertisement. Well, not advertisement, but people who I generally trust in terms of observations, trying to be very careful because they're not news people, but they're really good at providing observations. So I definitely want to make sure I give them as much exposure as I possibly can. So we'll do that tonight. Of course, we're keeping an eye on the Mets versus Phillies game because everyone knows how much I love Philadelphia. At least the Phillies. Well, you guys all know my issues with the Phillies. I like the museums. The museums are outstanding, and Rocky is an outstanding movie. Um, but they're fanatic. Well, you guys all know my history. So first, let's get to the book of the week. This is a book that I'm actually using quite a bit with the CCM test that I am working on right now. It's called Mid-Latitude Synoptic Meteorology, Dynamic Analysis and Forecasting by Gary Lackman. Probably saying that wrong, but here we are. Got it right from the AMS, the American Meteorological Society, as you can see right there. It is an outstanding book. It is something that is reprinted in 2022. It has a lot of helpful graphics here, a great description here of the low-level jet and jet stream dynamics. Um, let's see here, lower PV. I mean, look at these graphics, absolutely outstanding. So it's not a beginner book, but I would say that it's not a bad idea to get it at a younger age, let's say in high school, to start to get an idea on the overall themes involved. And if you're a novice as well, I mean, it's great to look and to follow along in terms of what is going on with the weather. Here's another great example showing the structures at various levels of the atmosphere. And it looks like the Mets just took the lead again. Well, you know who already did it? Lindor. He's been hot as hell. So that is the great book. If you want me to share again, here I'll put it up again. There you go. Mid Latitude Synoptic Meteorology. There you go. By Gary Lackman. This was an outstanding book. Very happy about it. And it has been very, very helpful of late. Now let's take a look at the fire. Now, I've been watching this and tracking this, and along with other people, the evolution here on the radar. This is not precipitation. This is smoke from this fire, and the fire has been very impressive. So I've been checking out Mark Jr. WX Man Franzi, okay, FRANZ. A great follow, especially for Southern New Jersey observations. Does a great job. Uh, Took this video earlier. We'll zoom in. Just an impressive fire. Just incredibly impressive. Unfortunately, it's produced a lot of damage already. And we got another video here from the same account. I muted it because of language, just in case the YouTube police get a little bit antsy. But look at this. This is in the industrial park. Let's see here. Industrial park in Fork River by his house, unfortunately. Mike Francis. That is some scary stuff. Has led to evacuations, unfortunately, and just a very, very dangerous situation. And look, I mean, we've been talking about drought and whatnot, but in this case, you know, not dealing with extreme drought here. It's dry. It's been dry. We've had some rain recently, but this isn't drought conditions. It's at a D0, so abnormally dry, which for Ocean County is about 48% of the county. As you head further south, as you head down towards like Bass River, that's where we're seeing more of the moderate drought levels. Bring this up because you don't just need drought. Okay, you can get these type of fires without a drought. All you need it to be is just a little bit dry, a little bit of one careless person, or an electrical charge. Pretty much anything can start this fire, and here we are. Now you have this uncontrolled fire, and the thing is that even a lot of people point out when there's a fire like this, oh, well, if they had cleared the brush. The one thing I would say about New Jersey, the state of New Jersey, that they are very proactive with their fire burns, just to cut down on the potential for these fires. Otherwise, I think we'd probably see them even more. But it just tells you in this weather pattern, uh, this is it's just sad to watch. And unfortunately, it doesn't take much to cause these fires. So I don't know what caused the fire yet. I'm not saying I do. But as we are moving into the warm season, and a lot of people are going to be camping and going out, and you have your fireworks with the 4th of July and all that stuff as we move into the summer, use extreme caution if you're going to have a campfire or anything of that nature, because this is the type of year where a simple, fun campfire can get out of control very, very quickly and very easily. And unfortunately, this is the result of that, um, where people might lose their homes and certainly their businesses. And something that you would see like out of California, but it's right in our backyard. So it's unfortunate. So, if you got a chance, give Mark a follow. WX Man FRANZ, capital WXMAN, capital FRANZ. Give him a follow. At the very least, you get some pretty good observations out of it. So definitely check that out. Now, while we're getting ready to discuss all the different weather patterns that we're going to be dealing with and answering questions, I just want to show you models. Why do I want to show you this? Well, it just kind of struck me before I started doing the live chat today and started getting prepared. All the models that I have available, and of course, there you have your model blend as well. I kind of want to show this because as a young meteorologist, you can easily get what I call model paralysis, where you start looking at every model that's out there. And if you do that and you're an operational forecaster, you'll never get the forecast done. And you'll be spending 4 hours of an 8-hour shift if you're in the National Weather Service, or even if you work for a private weather company, just staring at all the models. Models are great. Okay, they're a great tool, but you cannot get hung up on them. Okay, pick one or two. You can even check the National Weather Service analysis to see which ones are doing the best, which ones are doing the worst. Hint, GFS. So what I would say, what I use quite frequently, frankly, because it's just doing an outstanding job, is the European guidance, the European ensembles. For my mesoscale, I'm using a NAM and HRR, and then I go from there. Now, everyone's talking about all these AI models. What the AI model is basically set up, it's not driven by physical parameters, it's driven by statistics. And, it does use AI as a way to weed out the errors, supposedly. But if it's not based on physics, then it can't handle changing dynamics in a weather pattern, at least not very well. Not to say that the European guidance doesn't have its errors. It certainly does. I'll show you one right now, in fact. Let's take a look at some of the observations first. We know that the MJO is going from a neutral state to phase 7 and then phase 8 and back into a neutral state. And it's very weak. So the subtropical jet stream is pivoting northward. The signal here is relatively weak. as I was discussing this morning with premium members, the SOI is what I am following very, very carefully. It has generally been positive, so it gives you kind of like a La Nina type of feel to the weather pattern. Not driven 100% by La Nina, but the subtropical jet stream is a little bit weaker, a little bit better potential for a ridge around the Bahamas in the southeast. So you kind of get these little details mixed in. So when you have that, then you know what to remove. Okay. So a perfect example of this is on the European guidance, one of the best models out there right now statistically. And it's producing this solution here. And the first thing I thought when I saw this was that this looks a little funky. I like the idea of the polar jet stream getting pulled back. I like the dispersed way that it shows the subtropical jet stream, but this upper level low seems a little wonky. Why? Because it doesn't fit the parameters that we know that we're in terms of tropical forcing. Now, could you set up an environment where maybe you get a pocket of warmer air in the stratosphere to enhance the below normal heights off the East Coast? It's possible, but I really don't have any type of observational support to make that conclusion. So, knowing that the atmospheric dynamics, that the driving parameters don't really support this signal, should be a warning sign to say, I wouldn't play this up. I wouldn't advertise it on social media or anything else that, besides the fact it's beyond 240 hours, but that's another story. I'm going to look at some other guidance. And this is when you can start to maybe look at the AI, maybe look at the ensembles. You don't have to do this every day, but what you want to do is just find some problem areas and then go from there. So when I take a look at the ensembles, it doesn't support really that solution. It tries to drive an upper level low around the southeast, which somewhat makes sense in a phase 8, not really phase 7, but you can make an argument in a phase 8 for this time of year. But it weakens it and it kicks it right out. So it doesn't support a deep upper low over the uh, coastal waters of the mid Atlantic, but it produces basically a stalled frontal boundary with interaction of short waves with along that frontal boundary. And that is the AI guidance. The ensemble guidance, which I trust even more because it's a combination of a lot of physics solutions, okay, it's physics based. Well, it barely has any type of solution like that at all. Yeah, it has some below normal heights over the southeast, but no major upper level low, no signal like that, no major storm. So, what do I do as a meteorologist when I see this? Well, it tells me what is and isn't possible and what fits into the theme of the weather pattern. The theme of the weather pattern is not a stationary upper level low over the mid Atlantic, it's more of a progressive weather pattern. Your blocking is shifting northward as it normally does this time of year, and your subtropical jet stream isn't the strongest. If this was featuring more of an El Nino, as in the SOI was more negative, then I'd be more confident in the idea of a lot of upper level lows hanging around the region because you'd have a lot more short waves to work with in the subtropical jet stream, which is what we're working with when we're dealing with the mid latitudes, which is where we live. But if you have a La Nina field, well, those short waves are going to be weaker and they're going to be more progressive. So this makes a heck of a lot more sense than a big old upper level low sitting off the mid Atlantic coast. So I just kind of wanted to walk you through this just to show you how to use the model guides and how to use reasoning based on the environment that we are in. Now, currently, we have our cold front that is moving off the coast. Excuse me, I have an itch on my knee. I don't know why. So our cold front has moved off the coast. We have a little weak area, low pressure, no real precipitation. It is pretty quiet out there. It's really pleasant. I mean, if you're heading out to a baseball game or anything else over the next couple of days, really the rest of this week, weather is going to be absolutely beautiful. You can see that on our radar here on WeatherTap. Not much going on. We see that little faint hint of that fire that I was talking about. Let's see here. I did have the precipitable water value on here, but of course, there it is. As you can see, dry air is building in. So it's going to be pretty quiet. And there is some of our fire that's showing up here. So the upper level pattern is such that no real major storms. Everything's moving west to east pretty quickly. So our cold fronts are going to be moving pretty progressively. We have our subtropical gesture to the south here. I'm not seeing any type of signal for any major rainfall events, which again is why the solution after 240 hours on the European made even less sense, okay, because it just doesn't fit the pattern. So I'm not really seeing much in the way of any type of impressive lifting, but we do have the potential for a cold front this weekend. So I just wanted to break down this potential cold front. So in the upper levels, we have pretty good divergence and difluence. We have nice lifting over the mid-Atlantic, and it looks like we also have some pretty decent mid-level forcing as well at 850 millibars. Your 850 millibar low is passing to the northeast, so you got plenty of warm, moist air to work with out ahead of this system, and some pretty good mid-level frontogenesis, and plenty of moisture. As you can see, our precipitable water values are going to be pushing up to about 1.5, 1.6 inches. I'm not seeing much in the way of any type of vertical wind shear. It looks like the timing of this cold front is likely going to be in the 2 to 8 p.m. time period. So it will be capable of maximizing the CAPE values and instability in the atmosphere. And the latest QT from the European during this time period does suggest some potential instability in the atmosphere and possibly some weak thunderstorms. So that's seeing very strong CAPE and mid-level CAPE around 835 joules per kilogram. Surface-based CAPE is almost non-existent at this point because of this little feature right here. Slight neutral, slight stable layer right here around 900 millibars. But you kind of get the idea here. We're not really seeing any type of strong vertical wind shear, not really seeing any type of directional shear. Looks like run-of-the-mill type thunderstorms, capable of some heavier downpours. Not looking for anything severe at this point, but something I'll be watching very carefully on Thursday and Friday. That's it. Literally, that's it. After that cold front is quiet Sunday, Monday, and Tuesday. Unfortunately, we're not seeing much in the way of rainfall. And there just isn't a lot to really talk about in terms of the weather pattern. So I'm going to be relying on you for questions. I am starting to work on the summer forecast. I plan to have that out in mid-May, as I typically do each year, along with the tropical forecast. The hurricane forecast is going to be interesting this year because you can't really use an El Nino or La Nina based forecast. The Atlantic is warm, but nothing that's historic like last year. And there are hints of this tropical season being driven by the MJO, which means that if it goes into phase 8 and 1, it could get pretty interesting around the East Coast. But that depends on whether or not we actually get a strong Bermuda Ridge, Bermuda High Ridge off the west over the Western Atlantic. So we have to wait and see on that. I'm waiting on some more stratospheric data on that before I really get diving into that. With that, I am going to take your questions. Meanwhile, the Mets is still leading, so that's always good. So here's how we always play it. We answer all the questions that are in the live chat room on the premium website, premium dashboard. As always, they get all their questions asked, and then we go to social media. So if you have a question on YouTube or X or Facebook, we'll get to that. We'll pick the best ones, of course. Hint, if you're asking, hey, what's it going to do in my backyard? Most likely, if you're not a premium member, you're not going to get that answered. So, Card is back. It's good to see him back. Let's see here. Do you anticipate the ozone and temperature anomalies in the stratosphere to stay in the same location throughout the rest of spring and summer, or do you expect them to move around? The coldest spots don't park in a spot that gives us constant Atlantic ridge for the summer. I think that the evolution is still very changeable. So during the spring and let's say through June, you'll get a little bit more volatility involved. But I think by mid June on through the rest of summer, let's say August, you pretty much lock in to these stratospheric anomalies. And the reason why is because they start to feed back on each other. So you get the cold anomalies over the Western Atlantic, which allows for the 500 millibar heights to build. 500 millibar heights leads to a stronger ridge, which feeds back on itself, which keeps the 500 millibar heights elevated, which forces the stratosphere to remain contracted because it can't expand out into space. So it feeds back on itself. So as that process feeds back on itself, you start to uh, prevent any changes in your anomalies. If that starts to get going in the Western Atlantic, then you end up with a rather humid summer. So, something that I'm keeping an eye on. If it is dry and windy, don't shoot off fireworks. Yes, definitely do not do that. I would agree wholeheartedly. Let's see. What will be hotter this summer, Lindor or the weather? I don't know, man. Lindor's putting on a pretty good pace. This is normally when he's not doing as well. So I can't imagine middle of summer. Uh, in terms of the rest of spring, I don't see a lot of heavy rain in the often. If the MJO stays in a neutral state for the first half of May, I would not be surprised if May ends up with below normal precipitation, unfortunately. Uh, well, thank you, MTG. I appreciate it. Just wanted to drop a thanks for all your hard work. Great to have a reliable weather source. I appreciate it. Thank you. Far I know, but what are your early thoughts for severe weather mid next week? Um, I'm. hmm, Here's the problem with trying to forecast severe thunderstorms in the mid Atlantic is that the timing of these cold fronts, right? Typically around this region until you get to about July, well, late June, July, and August, you could set up a pretty good low level jet stream. Okay. And that can enhance your thunderstorms at night. Don't really see that all that much in May. So, or should I say April or May. So, when a cold front has the potential of passing through in the late evening hours, it reduces your potential for severe weather. And because severe thunderstorms are a convective property where you need mesoscale data, it's really, really dangerous to make any statements about that. So you should not, I'm sure others will, try to advertise any type of severe weather event unless you have a really, really impressive synoptic environment in place. Which more likely you'll have that set up in the planes. It's easier to make that statement in the planes where you have certain dynamics in place that can set up a pretty impressive event. In the mid Atlantic, that's far more difficult because you're dealing with the maritime air mass, which can short circuit even the best environments. So you really don't want to make it's not responsible to make any type of statements like that. And as far as like this weekend, again, I'm not seeing anything. So when I look at the skew T here, I'm not seeing any type of I could definitely see a thunderstorm warning, severe thunderstorm warning, but not widespread. It's not the right environment. So how do you know it's the right environment or not? Let me go back here real fast. So the first thing you key on are the winds here. Now, obviously, we have plenty of moisture to work with, so you could have some pretty good vivid lightning, but that doesn't give you a severe thunderstorm warning. What you want to look for is energy in the atmosphere. So your CAPE values are not really all that impressive. I mean, there's no sin, so that allows anything that does pop to grow. But your CAPE values aren't all that impressive. Why? Because in the environment that we have that we're working out, in fact, let's go back another hour here and another 3 hours here. And what do we see here as we move forward in this environment? So this is 11 a.m., 2 p.m., and then about 4 p.m., right? What is the environment in place? Well, we're missing a very key component. You know what that component is? Dry air at the mid levels. Okay, so you're lifting moisture in the atmosphere and you have to create a pretty significant cape, right? There's no real cape in this environment. What you typically want to look for a severe thunderstorm, just with the cape values, is that basically a goalpost where you get your LLC pretty low, and then you get your instability, and then a pocket of dry air, let's say around 500 millibars to 600 millibars. That right there is a warning sign. This right here is, well, a rainfall sign. The other problem here is that the winds, they're all coming almost from the same direction. There's not really any type of indication of vertical wind shear. So, for example, if I had winds coming in from the south here, west, southwest here, west here, and maybe northwest here, that'd be cyclonic. And that cyclonic motion in the atmosphere would lead to the development of mesolows and then possibly other type of lows, like with tornadoes, for example. No indication of that whatsoever. So then the other type of shear is speed shear. And the difference in winds from, let's say about, let's see, this is 950 millibars. So from 950 millibars up to 700 millibars, the difference in wind speed is almost non-existent. Now, you would expect it from the surface, okay, because you have more friction, more shear. But from the mid levels here, oh, this isn't pop at all. It's not that impressive at all. So you might see some, let's say the NAM on the very edge might show some impressive convective output. But again, you're talking about the NAM at the very edge of the model. You want to wait until about 48 hours out for the NAM, 18 hours out for the HRR. And this right here, not really all that impressive. So I don't see anything that stands out. Let's see here. Let's see. Why did it? Oh, hold it. I got some questions here in the premium chat, and I'll go back to social media. Stay with Marine Air for the win. Oh, yeah, totally. Yeah, we get that a lot. Is it just me, or does the big coronal hole and the small holes about it looks like something like someone sticking their tongue out or screaming? I haven't honestly, I did not check solar data today, but I do know that it's weird to see three coronal holes facing the Earth. That's going to create some pretty impressive interaction from solar winds. That is for sure. Let's see. I know I got to do a live chat just focused on the solar. I got to do. I'm probably going to shoot for that in the summer because I want to see whether or not we see a more significant drop off in the sunspots. Let's see. And do we have any questions on Facebook or X? Okay. Yes, I would agree. Yep, I got a friend that is out towards where that fire is. Luckily, they're safe. They're okay. But man, I mean, it's just scary to see that type of environment take place and just Just some very scary stuff. That's all I could say. It's very sad to see. Trying to post a link to a pic from space. Oh, I see it. I see it. Yeah. Well, yeah, it looks. The thing is that the sun. Let me go see if I can pull this up here. Solar. Let's see if I can pull up space weather while I'm doing this. Okay. So, spaceweather.com is an outstanding source for a lot of your solar needs. So, as you can see, we have our sunspots, which have been declining of late. And the discussion is on the coronal hole. Now, it does look like a bit of a funky grin. They got one here, two. Looks like the sun is yawning at us. So when you got this facing the Earth, what happens is that it increases the solar winds and it impacts the Earth's atmosphere. And this is part of why you get a lot of like your auroras and all that stuff. Um, and it's certainly having creating some havoc with some satellites as well. So the more that we get this showing up, the more it impacts the atmosphere, especially the ionosphere and whatnot. So it can be pretty funky. Does this impact the weather? Not really. Not directly. Changing dynamics in the sun, let's say with less sunspots, does allow for more buildup of ozone in the stratosphere, which can lead to a warmer stratospheric environment overall. There has yet to be any type of connection between that and winter storms or storms in general. But it does certainly give you the potential of having a warmer stratosphere, which increases your potential for high latitude blocking and and higher heights at 500 millibars over the higher latitudes, especially in the winter seasons. So there's our sun. That's what we were talking about earlier. So anything on X or Facebook? Nothing. It is quiet out there. Even New York City got down to 36 on April 12th. That is true. Now, it is disappointing. I just noticed someone put a downvote on a weather feed. How do you do downvotes on weather feed? Maybe. Ah. Well, it's not even winter. I expect that in the winter. Because, I want 5 feet of snow. I'm like, no, sorry. But that is funky. That that's strange. And the whole thing, the one thing I've learned with social media is that you meet all sorts of very, very interesting people. Um, and some people take a forecast to be very emotional. I'm not sure why. If there's anyone who should be emotional about it, it should be me. I'm making the forecast. I want to be right. But there are some people who take it to a whole other level. Threats, anger. I'm like, it's just snow. It's just rain. It'll be fine. That is true. That would be great. I don't understand the sunspot that well. Yeah, we definitely have to do more in depth. I have to plan. I don't want to do it without planning it out first because it can be tricky. And I do want to double check some of the theories that are out there because I'm not a solar scientist. I studied the information. I put it as part of my forecast, but I am more of a student like you than I am a quote unquote master. So definitely want to double check with some of the research out there. Mary Miller asks, can you explain what the blue on this map represents? And we got the map. Oh, okay. I think I know what you're talking about. Let me make sure. Um, hey, honey, can you come over and see which blue that they're talking about? let's see here. 108. So what are they talking about? Is this blue?
That's blue. This is blue right here.
I see. Okay.
And
Okay.
there's blue in there too.
Joys of being colorblind. Okay. So what does the blue mean on the map? And let's see here. Okay. So the blue on the map, along with the greens and the yellows and the oranges, represent lifting. Okay. Now, what we're looking at in this map is cyclonic relative vorticity, 500 millibar heights, and wind velocity in knots. So, what the vorticity is showing here, again, this is relative vorticity, is showing the lifting in the atmosphere. So, when you're studying the lifting in the atmosphere, your strongest lifting is actually here. Think of lifting like a ramp, right? So, when you have the lifting moving into the region, it's lifting all the moisture out ahead of it, right? So while that's happening, it allows for precipitation to build. So what you're seeing here is the leading edge of lifting, rising motion in the atmosphere. So what we look for is PVA and NVA. Now, PVA is positive vorticity advection. What's positive vorticity advection? The PVA, the vorticity atmosphere is increasing as it's moving in, right? So it's rising. NVA is where that lifting is decreasing. So let's say you're right here. Okay, let's say you are right in northwestern Connecticut, right? You right now are under an area of PVA. Why? Because the lifting that's moving into the region is rising. Then you are in an area NVA by Sunday because the lifting is falling off, is decreasing. So you have rising and sinking air. So that's what the different colors represent. Okay. That's some great questions. Good job, guys. It's almost 8:40 p.m. What do you know? And just an update, the Mets are still winning 2-1. So there we go. So I think the next book I'm going to do next week is going to be one that's a little bit more technical. Maybe I could find one on solar weather. That might actually work out really well. I think I have one in my library. I got to find. Let's see. Do we have any more questions? I think. See, this is going to be the struggle as we move through spring and summer. We have this every year where there just isn't a lot going on, unfortunately. And yes, and we definitely did that. So let's see here. I'm going to do another check to see if there's any more questions. Oh, there we go from Norm. How do the standard weather apps generate their forecasts? Ah, ha, ha. Oh boy. All right. So this is how they generally do it. You first get the raw model data. So let's say the GFS. You download the raw model data from the National Weather Service. You then make some algorithms based on that data to create, let's say, clear skies, a big sun, um, or if it's going to rain, a big raindrop, snow, a snowflake, so on and so forth. That could all be done via coding. Um, Most of the weather apps just take the pure GFS guidance, which we all know is the best model, obviously, and spits it out. There's no forecasting involved. There's no adjustments. Hey, if there's an error, that's what's in there. Now, when you get the hourly updates, that usually involves the HRR guidance for the first 18 hours. So that can be pretty volatile. And sometimes it does really well, and sometimes it really, really horrible. And then some of the apps out there, they'll take the AI guidance and try to adjust it based on the previous hour's errors. So for example, if the model data was saying it's going to rain and the observations are coming in cloudy, then the model guidance will adjust itself to reduce um, the percent chance of rainfall. So if it was saying 80%, it didn't rain at all. So next hour, they'll adjust it down to 40% and build its way back up. But the problem is that if you have an actual meteorologist doing it, they can actually see the radar, see the observations, and say, hey, this forecast isn't working out. We need to scrap it and go with a different guidance and go with a different solution. But your weather app never does that until it's too late, which is why I always say if you want a bad forecast, you get what you pay for. Weather apps are the best thing that ever happened to me because that's how I make my money. Because, well, if you want a good forecast, you clearly need to get someone who actually knows what they're looking at. Weather apps are just, well, they're horrendous. But hey, I mean, if you don't want to pay for it, you just want to get something free, I would say you're better off just going with the National Weather forecast than a weather app, because at the very least with the National Weather Service forecast, you get someone to actually look at the forecast. Don't some apps just spit out the GFS forecast every 6 hours? Yeah, that's pretty much it. And a lot of them don't use the European guidance because you have to pay for that data. So the GFS is free. So, well, aside from your tax dollars. So you're basically getting free data with a model that is, bless you, that is performing the worst in the world. And that isn't even an exaggeration. It's true. The model has been just absolutely horrid over the past 6 weeks, 6 months, 6 years, 6 decades. Well, not decades. It hasn't been around that long, but you get the idea. Let's see. But yeah, I mean, that's generally how a weather app is made. Not the best, but if you want to use it as a pinch and just basically my suggestion is whatever, if unless it's really sunny out. It's great if it's sunny out and there's nothing going on. Like today, for example, or tomorrow. Tomorrow's going to be perfect day to use a weather app because there's nothing going on. So it'll be sunny, it'll be quiet, ballpark mid 70s, a few lower 80s. Very easy forecast. Can't get it wrong. So, right? 72 degrees. Yep. Which is why in the summer, every time the 18Z comes out, people go into hurricane panics. Yeah, pretty much. Absolutely. I mean, one of the worst things that impacts the industry overall is you get the GFS coming out producing some ridiculous nonsense and everyone flips out over it. So, not the best thing, I could tell you that. Well, I think that we answered all the questions for tonight. Overall, I think outstanding job, by the way, with all the questions, especially asking about with the PVA. Um, it's always good to ask those questions. And again, book of the week, Mid Atlantic Synoptic Meteorology, Gary Lackman. Uh, Pretty soon I'm going to run out of books in my library, but that just means I need to buy more. There you go. Yeah. Oh, yeah. That's a great idea. We'll definitely go there. We'll see what they have in the atmospheric science section. Hopefully something. But I think that overall has been good. Thank you as always for joining the live chat. And for those of you in Ocean County with that fire, hopefully you're safe. We're pulling for you. And as always, stay safe out there.